Welcome friend in today's lecture 2 for the same chapter, lesson first, that is chemical reactions and equations. In today's particular chapter we are going to learn 2-3 topics. The first topic is how to write down a chemical reaction. The chemical reaction can be written in two forms. As you see in the screen, the two forms of the chemical written equations are shown. One is called as an word equation, second is called as an formula equation. Now in word equation you can see that a word magnesium is written in word that is alphabets, plus oxygen is written and the arrow sign is shown, and two reactants are shown, that is magnesium plus oxygen, and the arrow sign is shown and the product is shown on the right hand side, that is magnesium oxide. So 3-4 things we need to notify in this. Okay, first of all, on the left hand side and right hand side there are two parts. In left hand side we write down reactants and on right hand side we write down as products. So reactants and products. So always the reactants converts itself into the products, chemical reactions. In magnesium reacting with oxygen, so now what I am speaking, magnesium as an substance reacting with oxygen. So a plus sign is shown in between and an arrow is shown which shows the direction of the reaction going from one reactants to the product side. And magnesium oxide, as we have seen in the previous video, a white color powder was formed and magnesium oxide was formed. The same reaction can be written in the form of a formula. That is, you can say that magnesium, a symbol is written Mg in short, plus oxygen O2, O is the symbol, and because we are writing in the form of two elements joining forming a molecule of O2, because O2 is only available, oxygen as a single element is not available, we need to understand certain things like this. Arrow sign is shown and magnesium oxide is written on the right hand side, which is a product. So left hand side and right hand side, as the number of reactants are more than one, we put a plus sign inside it, and on the right hand side also in the same way, if the products are one or more than one, then if it is more than one, we have to put a plus sign in between, that these are the two products which are formed. Here it is only a one product, so we will start with the next topic here only, that how to balance such kind of reaction. Now balancing means, what you understand with the word as in balancing, because whatever the number of reactants, whichever the number of elements participates in the chemical reaction, the same element comes out as a product but in the different form. I will give you a simple example, like carbon is participating, coal, we are burning a coal. So carbon in the presence of oxygen we are burning, so carbon dioxide is formed. So here nothing is changing, carbon is an element which was before also there, oxygen was an element before also there. Now they have combined in form of an electron sharing and turned to a carbon dioxide. This carbon dioxide is a new molecule, but does not make sense that carbon and oxygen has turned into something new. They have combined to form a new substance, but carbon and oxygen are still the same element which was there before. So the number of elements, carbon and element which was put inside as a reactant, the same element has come out as a product also. Here we are going to take, as you see in the on the screen, I have just written one equation of iron, that iron in the presence of steam, iron, pure iron as an element, iron you know it, Lokhan, that is we see in the form of an greyish color substance, as I told you before. This iron as a powder, maybe we pass a steam on it, it turns to iron oxide, Fe3O4 plus hydrogen gas is released. So Fe3O4 is formed. Now here the Fe3O4, Fe, H2O and H2, you see Fe and H2 are on the left hand side and Fe3O4 plus H2 are on the right hand side. So here Fe plus H2O is a reactant and Fe3O4 and H2 gas which is produced is a product. So every element or a molecule, first of all, first step is we will put inside in the form of an brackets. Brackets we are going to put it. As you see on the screen, as I have already written the reaction and put in the form of an brackets. Now inside the bracket you cannot manipulate or change anything. In the furthermore upcoming time, maybe in the next lecture, maybe in the continuation of this lecture, I am going to explain you the previous thing that we already learned in 9th standard, how the ions are formed and how the ions form a molecular substance. This will be a kind of a revision for you. Here as you see, I have written elements name first of all, that is in the second step I have written the element name, iron, hydrogen and oxygen. These are the only three elements which are participating. The same number of element, the same type of an element is going to be in the form of a product also. Maybe in the combinations might change. So the number of atoms on the left hand side which is shown, you see in the box iron there is no other one except then nothing is written, that is 2, 3, 4 is not written. So you can see that nothing is written, that means it is 1. In H2 you see that 2 hydrogen, and in oxygen nothing is written on the right corner. So you see this is oxygen is also 1 and hydrogen is 2. So on the left hand side, number of atoms as you see on the screen, okay, left hand side you see there is 1 iron, 1 oxygen and 2 of the hydrogen. In the same way on the right hand side as a product you see iron 3. So 3 iron is there, iron here it is written as 3, oxygen it is written as 4, Fe3O4 and H2 is a gas, so it is H2, 2 of the hydrogen is combined. Single hydrogen is not available, as here also it is in the form of a gas. H2 is a diatomic molecule. So here on the right hand side H2 is obtained. So 3 iron, 4 oxygen and 2 hydrogen is obtained, right? So I have written in the form of an elements, a number of atoms. Okay, on the left hand side these are the number of atoms and on the right hand side these are the number of atoms which are obtained. So in the third step we are going to start understanding that how we are going to balance this equation. So the number of atoms which are there on the left hand side, the same number of atoms it should be there on the right hand side, because number of atoms cannot change. The number of atoms which are participating as a reactant, the same number of atoms should come out in the form of a products also. So the prime requirement is to balance it out. So number of atoms on the left hand side and number of atoms on the right hand side. Here in this particular screen you are able to see the number of elements. Here first of all we will start balancing oxygen. Here oxygen as you see is 1 on the left hand side, on the right hand side you see it is a 4. So first of all we are going to multiply this 1 with 4, so it is going to turn as 4 number of oxygen. So what we are supposed to keep here is outside the box, that is in maths you understand as coefficient. X you put coefficient in left hand side of this particular x. In the same way left hand side of this particular box you are going to put 4 in H2O. So H2O, as you are going to put 4, this 4 is going to be applicable for hydrogen also. Now if you see there were 2 hydrogen on the left hand side, so it will be multiplied by 4 and it is going to turn 8. So you have to take in consideration the number of elements participating with the particular element or an atom you are making a change. So in this box the hydrogen is also changing, so you have to see with your efficiency that these things also need to be settled out. So 2 of the hydrogen multiplied by 4, now it turns to 8. Okay. Furthermore, if you see on the right hand side, the iron oxygen was 4, which was already balanced, but the hydrogen was 2 only. So we have to multiply 2 with 4 to make it 8. So we are supposed to put 4 on the hydrogen front also as a coefficient and make it 8 total by multiplying it by 4. So as you see I have put 4, furthermore hydrogen also, that means as a coefficient of hydrogen also. Now the last thing which was unsettled was iron, that on the left hand side iron was 1 and on right hand side the iron was 3. So in left hand side we have to multiply by 3 and make it 3. So we are putting 3 as a coefficient of iron. So if you see now, after multiplication of all, the iron on the left hand side and right hand side equalize as 3, hydrogen equalizes on left hand side and right hand side as 8, and oxygen also on left hand side and right hand side equalize as 4, right? So this particular reaction on the last particular after balancing you need to write down in the form of a complete formula equation. So 3 iron plus 4 water molecules combine to give you iron oxide, that is Fe3O4 plus hydrogen, and the coefficients are supposed to be written, that is 3, 4 and last hydrogen as 4 on the right hand side. Also you need to write down the states of matter, that is iron is in the form of a solid state, water molecules was passed in the form of an steam, so it is in the gaseous state. Iron oxide is formed as a product in solid powder form, that is Fe3O4S, it is going to be written, and hydrogen gas is evolved out as G. So this is how we need to complete the reaction. On the next exercise, backside of the on the exercise that is I am showing on the screen, this particular exercise need to be balanced by you as in practice, and this complete exercise you need to complete it, right? The reactions are given in word equations also, and the reactions are given in the form of an formula also. So both of them you first of all write down, you put in the form of an box, you write down the number of elements on left hand side, you write down the number of elements on the right hand side, they will be obviously same. You put down the number of atoms on the left hand side, you put down the number of atoms on the right hand side, and start equalizing in a clever manner in such a way that left hand side number of atoms and right hand side number of atoms becomes equal, right? So you need to consistently see the number of atoms on left hand side and right hand side becomes equal. And lastly, you balance out this equation, write down the balanced equation as a final equation of yours. Also, if possible, write down their states of matter. That will be a nice on your side that you understand this type of reactions also, right?